Yeah, okay, so clearly this whole silent approach isn't working. Some of you required direct instruction. You'll notice there's some stuff on the board. You're going to want to get going on that. Sorry, I was trying to do the quiet, you'll figure it out approach. Most of you did. Thank you very much. Oof. Yeah, that's our first system. And I know that the notes are headed as special types, and you may not recognize anything about this as special. No, a normal person, myself included, would never in a million years look at this and just through inspection say, oh yeah, this is one of those. So as far as you know, this is just business as usual. As you get this written down, that some of you already have it written down, what's going to be probably our money column? Who do we like? Yeah, probably the Ys. Just because the 3s can be easily modified to make 6s. So as you get going on this, go ahead and let's all agree that we're, as a class, I mean, you don't have to, but as the guy with the fake pen and the recording up here, I'm going to kill the Ys. So go ahead and start prepping. How are we going to do that? Yeah, and good job. And you don't even need negatives, right? Because we already have the dynamic of negative, positive, positive. So sign modification is not necessary. We're just going to multiply the top 2 rows by 2, and that'll be that. So go ahead and get that done, and then we'll get caught up to you here in just a second. And after this, just FYI, I'm going to show you some videos today. I know that's a pretty un-Ahern thing to do, but I had said before that I wanted to show you some sort of visual representations of what this is all about. And I found my new favorite YouTube channel. Okay, that's not really true. It's not my favorite, but as a math guy, it's my favorite. Okay, even that's a lie. I have others, but still, it's really good. And I found some videos that I want to show you. I had 4, which I don't know if I want to show you all 4, because you might just be over it by the time we get through with a couple, but we'll see. So anyways, in the meantime, let's solve this system. I'm going to get caught up to you now. Our new modified top row should be negative 8x minus 6y plus 6z equals 6. And our new modified second row should be 2x plus 6y plus 10z equals 26. And then our non-modified bottom row should just get copied over. So 5x plus 6y plus 2z equals 10. Yes.
Do you put R1, R2, R3 values?
I will now. Yep. Remember, once they're modified and ready for row operations, that's when we should bust out the labels. So this is going to be my R1, this will be my R2, and this will be my R3. Do you already? What is it? Okay, so you're okay. Good. Yes. So let's get caught up with Bryce here. Right now, if you're just at this point, again, you're not going to see anything about this. This just looks like we're doing what we've always done. What you working on there? Oh yeah, nice, good call. It's a little early for that, don't you think? Okay.
Like having Taco Bell.
Hey, don't knock it. Yeah, so the prep work is done. Like, you've done these problems already, you know what to do. So now that we've got it modified in our target column, remember, was the Ys, we're clearly going to do R1 plus R2. And then we're also going to do which other combination? Good job. So those are where we get the combos that we want, because we're trying to kill the Ys. That's the goal here. So if we do R1 plus R2, We get negative 6x's. The y's cancel. We get 16 z's. Yeah, saying something like, is a pretty normal response to what's about to happen, right? And then when we add the constants together, we're going to get 6 plus 26, which is 32. And now we're going to perform row 1 plus row 3, and it will become more evident. The light doesn't fully shine after this step, but it becomes much more possible to see the light. So when I add row 1 to row 3, I get negative 3 x's. And my y's, of course, cancel. And for z's, I get 8 z's. And then for the constant term, I'm doing 6 plus 6, or 6 plus 10, which is 16. Right. So this, it's kind of one year to the next. I do a better job of this in Algebra 1. Some years I talk about it a lot. Some years I don't talk about it enough. But something is going to happen here. And it's not something that we made happen. It's just naturally, and one of the videos I show you will sort of illustrate maybe to some extent why what's about to happen is going to happen. Yes? No. Let's get to it. So let's first just talk mechanics about what's about to happen. You would identify, half of you, if I gave you this 2x2 system down here, half of you would look at the x's right away and say, I have to multiply the bottom equation by -2, right? The other half of you might look at the z's and say, I have to multiply the bottom equation by, yeah, you guessed it, -2. And whenever that same operation is going to make two things happen, then we've entered the func zone. That's what today's lesson and the videos primarily are about, is this. When I modify the bottom equation, what do I get? Correct. Good. Now, if we take, and I'm going to draw a connector between them just to make sure that everybody's eyeballs are in the correct place. Those two equations with the green arrows connecting them are the ones now that we want to add together, right? So we're still just standard practice, par for the course. Like we did this before last week. But when I add them together, the 6x's cancel, and we did that on purpose. So you go boom, boom. And then you're used to getting something here like 5y or -3y, and then you're like, oh, crikeys, the z's cancel too. And I didn't mean to, it just happened. So now the equal sign comes down, and then I add the 32 and the -32 together, and what do I get? 0.
Everything was 0. Good job.
So, no. So what happens now is I have to add a 0 to the left-hand side. Normally what I tell you guys, and I've been telling you this since Algebra 1, is when things cancel out, we generally don't put anything there. We just cross them out and move on our way. But this 0, I'm actually going to change his color because I think he's important and worthy of discussion. Why does this 0 have to come, the red one? Because something has to be there, right? Like you can't have an empty side. Like 0 technically makes it not empty. Like 0 is a number. It gives the equation substance. So at this point, by putting a 0 in the place of all the x's and z's that canceled, I now have a numerical equation. There are no more x's, there are no more y's, there are no more z's. All that you have here is a simple question. And if this question is difficult, just rest assured that you're making it too difficult. All I have for you here is a simple question that like a third grader could answer. Is what you see in the box true or false? It is true. Therefore, this system has infinitely many solutions. And I'm not going to go into detail as to what that means. I'm going to let the video show you that here in a couple of minutes because I think the video does a good job. But I do need you attentive when watching the videos. They're nice, colorfully, well animated. I watched them last night and was like, man, this guy's really good at his craft. He makes good videos. No, I sometimes have seen people abbreviate it as IMS, and that's fine with me as long as you know what it's. Huh? That would be if these were, and again, that'll come up in the video. They're not lines, Seth. They're planes. Remember. Yeah. So as you'll see in the video, there are multiple possibilities as how the planes are oriented in space that can cause there to be infinitely many solutions. So if it were a 2x2 system, just if it had started as a 2x2, then you're right. Good memory. That would mean that the lines are sitting on top of each other. But these are planes, and it doesn't necessarily mean that, as you'll see. Okay, it simply means what it says. There are literally infinitely many solutions to this system. It doesn't mean that everything's a solution. It means that there are infinitely many of them. There's a difference between those two statements. Now, I want you to know something, that what just happened would have happened no matter which variable you had picked. I went through and I kind of debated, do I want to show them this? And I've kind of made my mind up right now that I don't think I want to, but I'm just going to tell you this. You can take my word or you can go try this later. Let's say that at the very beginning, way up in the upper left corner of the screen, that we hadn't decided to kill the y's. What if we had killed the x's? What could we turn all the x's into? 20. So we could have multiplied the top one by 5, the middle one by 20, and the bottom one by 4, right? And I worked through this last night just to tell you the same thing will happen. It'll look different, like you'll be working with different variables, but the same weird thing will happen later. When you get to your 2x2, it happens again. And then just to make sure that I had all my bases covered, you guessed it, I went through and I also murdered the z's. What would we turn all those z's into? 30s, and we would need to multiply by one of them by a negative in this case, right? So like I think when I went through and did this last night, I did the top equation times -10, and then the second one by 6, and the bottom one by 15. And that guaranteed that I'd get -30, 30, 30. And when the z's cancel, you get a 2x2, and guess what? It happens again. So it's going to fall out into your lap regardless of which pathway you take. I feel like if I put this problem on a quiz, I'd like to think that literally everybody would have chosen the Y's. But the point is that if Mason was like, man, it's too easy, I'm getting bored, I'm going to make it a little harder. If he killed the X's, he'd get the same result, right? And if Evie killed the Z's, she'd get the same result. I want to make sure we're clear on that. So when you get to the end and what's in the box is just a number and a number, all of the variables have eliminated themselves. What's in the box, if it is a true statement, then there are infinite solutions to the system. Okay? Let's do another one. You're going to have to get that snack just done with and open so that I don't have to listen to it anymore. Trying to do it slow like that just makes it 4 minutes of misery as opposed to just like tearing off a Band-Aid, just get her done. It's like 5 seconds is all it is. Yo, nice. The manufacturers of these things need to start making classroom-friendly packaging, silent packaging, don't you think? That's a great idea.
That's usually only happens. Silent. That's just Apple's fault. Look at the eating of the seven. I just straight through the stock wall.
Thank you, Ellie, for that. Sometimes I think I'm the only one who is thinking, okay, so anyways, good job, Ellie. Way to get the ball rolling there. You know where I'm headed with this. And so I just wanted to make sure that you had one example. You're not going to probably do any homework, work assignment kind of stuff today. Today, what I wanted to do was come in and show you what these look like in practice. And then I wanted to just kick back and watch a couple of videos that are going to give you, I think in fairness to you, it would be good for you to see what's actually going on behind the scenes, like in space, okay? Yes, Tristan? Yeah, I mean, if you did anything other than kill the X's, I wouldn't call you anything other than maybe a little weird. Like the X's are the obvious choice here, right? In fact, I would say they're an excellent choice. Yeah, and we don't have to even multiply it by -2. The sign dynamic is already correct. Remember, with signs, if one of them is different than the other two, then you don't have to modify, right? You'll just have to use the correct rows. So if I multiply the top equation by -2, I'm going to get -4x plus 2y plus 2z equals 28. Everybody okay? So your modified system looks like this. And this, remember, is where we want to now assign our labels. There's no sense in prematurely putting labels on things. Like if we're not going to do any operations with them, there's no sense in labeling them. Label them once the pack, the system is ready. So now we have our R1, R2, and R3. Who's our first operation going to be? For sure, R1 plus R2. And when we add those together, what do we get? Correct. And just like before, this choice that we've made, that Tristan helped us make, that we all would have made, it doesn't mean it's the only choice we could have made. We just picked what we perceived as the path of least resistance. And so there's R1 plus R2. What's the other combo? So we want to do R2 plus R3. Good. No mistakes there at all. I appreciate that. Good job. And so again, this one I think is even more obvious. Like some of you saw that last one without even doing the actual multiplication, but this one's really up in your business, right? It's pretty hard not to notice, I think, that what's happening here is that my top row of my 2x2 and my bottom row are basically like essentially what we would call parallel lines, right? If we were just talking now, not in terms of 3 dimensions, but just a line, that they're basically the same line with different y-intercepts, and so they're parallel to each other. But mechanically, to make this work, let's go ahead and do what we need to do. Let's multiply the top row by -1. So I'm going to take the answer to that, and I'm going to just write it down below. So that's going to become positive 3y plus 4z equals -9. Correct? So what I've done is I put myself in a position now where I've got this 2x2 right here ready to rock and roll. So when we add those together, again, we'll enter the func zone. You'll know right away. You see it coming from a mile away. When you add them together, your y's cancel. Maybe on purpose. Maybe it was the z's. I don't know. But then you go, oh, look, the z's also cancel. So we know that to fill the void on the left side, we have to put a placeholder number of 0. And now all we wait for is the answer to the question, what's going to happen on the right? And clearly it ain't going to equal 0, right? It's going to equal -36. So yet again, it comes down to a simple question that I think, again, I'm safe to say a 3rd grader could answer. And I know I don't mean any insult when I ask this, but is that true or is that false? It is false. And so when the statement is false, we just simply want to take and just say, okay, you're a load of hullabaloo, right? 0 does not equal 36 or -36. What does that mean about this system? There is no solution. Correct. So those are the 2 possible things that can happen. In this video that I want to show you, I have multiple options, but I thought maybe I would show you. So here's your options, because you're the one that is going to watch these. I watched them all last night. I like them all because I'm a dork. But the first video explains. It's pretty abstract but interesting. It explains why 3 variable equations graph planes. I thought maybe I would show you that. The second video will explain what the various types of interactions of 3 planes in space can be. The third video I will skip because it's the guy teaching us how to solve a 3x3, which we've already gotten good at. And then the last video is a little bit weird, but I might show it time permitting. So you guys down for some videos?
Yeah.
Okay. Listen, I shouldn't have to say this, but I do because I work with teenagers and you're really good kids, but you can't be like on your phone or talking, okay? I would just like you to kind of enjoy the video. So I'm going to stop the recording because I don't see the sense in putting a recording on the video itself. That's just taking up space. So then I'll post links on Canvas. If you want to rewatch any of these videos, I'll link them to Canvas later after I'm done here. Okay. Cool.